What is up, kabsat? And this is Engineer Kuya DJ. Nakikita nyo ngayon dito sa inyong screen ang isang problem under steel design. And it's actually a problem under compression members. Itong problem na to, baka hindi nyo pa nakikita, no? It's actually one of the practice problems that I gave in a given YouTube video. And the name of the YouTube channel is Kippap Education. Yan. So kung hindi nyo pa nakikita yung aking lecture sa compression members sa steel design, follow Kippap Education YouTube channel. Check out the video first, then balik kayo dito sa akin. So, isosolve natin to ngayon. And it's a problem similar to November 2019 board exam. So, two channels are welded at the tip of their flanges to form a built-up column. The unsupported column height is 8 meters. And the column is braced against side sway in both directions. Okay, tandaan, both directions to. At 5 meters from the bottom of the column. The bottom end is fixed while the upper end is hinged. So, fixed yung baba, hinged sa taas. Then, given sa atin yung properties ng isang channel. We have the area, 4,500 square meters. Overall depth of 250 millimeters. Thickness of flange, 15 millimeters. Thickness of web, 10 millimeters. Moment of inertia, about X and Y centroidal yan ng isang channel. Flange width, 90 millimeters. Distance from the back of the web to the y-axis. Ang y-axis na to ay yung centroidal y-axis ng isang channel. And we have 24.9 millimeters. So we are asked to solve for the maximum slenderness ratio, design compressive strength of the column. So, since hindi binigay sa atin kung anong method, we will try to solve using the ASD and the LRFD method. Madali lang naman siya, no? Kung NSCP 2015 kasi ang pinagkaiba lang sa kanila ay yung multiplier. Yung isa ay phi, yung isa dinidivide sa omega. Then, if the design compressive strength is composed of 20% dead load and 80% live load, determine the total service load that it can carry. So let's solve this figure ng ating column section. Okay, so the figure is not to scale and drawing ko lang yan. So hindi siya ganun kagandahan. Basta importante maintindihan natin yung cross section ng ating column. Alright, so yung ating overall depth we have. Label lang natin. So, overall depth is D, ito. That's 250 millimeters. Then, we have the thickness of the flange. Ito. This one is 15 millimeters. Thickness ng web. Ito. This one is 10 millimeters. We also have the width of the flange. So, it's 90 millimeters. Ito siya. From tip to tip, syempre, diba? And then, yung distance from the back of the web to the y-axis. So, i-label na lang natin dito sa kabilang channel. So, let's say ito yung centroidal y-axis ng isang channel. Therefore, yung x ay, ito, from the back of the web, hanggang dito, sa may y-axis. So, that's 24.9 millimeters. Right? Ngayon, since ang hinahanap ay yung maximum slenderness ratio, kunin natin yung radius of gyration muna nung ating section about the x and the y-axis. Centroidal x and y-axis. So, ano muna yung centroidal x-axis? Siyempre, ito. Dito sa gitna. And, nasa kalahati lang siya nung 250 mm na height, di ba? So, this one is 125 millimeters. Then, yung ating y-axis naman, sige, ilagay na lang natin dito. X, ito yung y-axis natin, centroidal y-axis, nasa may tip ng flange ng ating column. Alright. So, para makuha natin yung mga radius of gyration, mas mauuna natin kunin yung ating moment of inertia na dalawa, no? Mas madali na kunin dito yung IX. IX bar actually, no? Pero moment of inertia about the centroidal x-axis. Bakit? Kasi yung centroid natin, nandun mismo sa kalinya mismo nung centroid nung ating dalawang channel. Diba? Yung gitna nung isa, nandun din sa gitna, nasa x-axis din dun sa gitna nung isa. Kaya, ibig sabihin nun, hindi tayo gagamit ng transfer formula, actually, no? Parallel axis theorem. Though, pwede pa rin naman, kaso yung mga, di ba, AD squared, yung mga D natin magiging 0. So, di kailangan, no? So, technically, ang ilalagay lang natin sa ating IX ay 35 times 10 raised to 6. Tapos, since dalawa sila, times 2. So, the answer for IX is 70 times 10 raised to 6 millimeter to the fourth. Now, let's have the moment of inertia about the y-axis. So, IY, add agad natin yung centroidal moment of inertia ng dalawang channel. We have 3 times 10 raised to 6. Tapos, since dalawa sila, di times 2. Plus, AD squared. Kasi, yung centroid na ngayon, malayo mula sa y-axis, andito. May distance na yan. Eh, diba? 90 millimeters itong from back ng web hanggang sa tip ng flange. So, para makuha natin yung distance na D na to, we have 90 minus 24.9 millimeters. So, 90 minus 24.9 is equal to 65.1 millimeters. So, plus 2 times AD squared. Kasi, same din, 65.1 din mula dun sa isang channel. So, 2 times area, that's 4,500, D squared. So, 65.1 squared. Right? So, take note natin ha. This one is yung, this one are your I sub Y bar. Tama? Then, ito yung A, ito yung D squared. Right? So, solve lang natin. IY is equal to 44 and 44.142 times 10 raised to 6 millimeters to the fourth. Okay. So, meron na tayong IX and IY, makukuha na natin yung R sub X at R sub Y. So, for the radius of gyration at about the centroidal x-axis is the square root of IX all over the area, total area of the cross-section. So, we have square root ng 70 times 10 raised to 6 all over yung dalawang channel. So, 2 times 4500. Right? So, the value is approximately 88.19 millimeters. Then, for RY, ganun din yung formula. Square root of IY over the area. So, we have square root ng 44. We have 44.142 times 10 raised to 6 all over the area. That's 2 times 4,500. And the radius of gyration about the y-axis is very near to 70 millimeters. So, we have 70.03 millimeters. So, nakuha na natin yung radii of gyration. Okay? Radii of gyration of the x and y axis. Okay, ngayon, para ma-solve natin yung slenderness ratio na kailangan. Alright, so dito tayo sa may slenderness ratio ng ating column. So, sabi sa ating problem, the column is braced against side sway. Pero in both directions, so kalimitan sa mga problems na nilalabas sa board exam, yung direction lang na brace against side sway ay sa may minor axis. Pero in this problem, both directions merong bracing. Let's consider yung figure sa ating column ngayon. Yung side view niya lang naman, di ba? So, yung top part is hinge, the bottom end is fixed. Tapos andito yung ating lateral brace. Ibig sabihin nun, meron tayo ngayon dalawang unbraced length. Isa ay 3,000 meters, at least 3,000 millimeters, which is 3 meters, and the other one is 5,000 millimeters or 5 meters. Right, so para ma-check natin ng mas mabilis, yung makuha natin yung mas malaking slenderness ratio, kunin natin kung alin yung may mas malaking effective length. So ang effective length nito, KL, is what? Diba? Hinge sa taas, tapos kung lateral bracing yung andito sa baba ng 3 meter portion na to, hinge din, diba? So hinge at both ends, that is 1. 1 times the length na unbraced length is 3 meters, so we have 3,000 millimeters. Yan ay 3,000 millimeters. Next, yung KL naman nitong nasa baba. Ang K na value ngayon ay 0.7. So we are using the theoretical values of K muna, no? So 0.7 to kasi fixed sa baba, tas yung lateral bracing ay hinged. So 0.7, then 5,000 millimeters. The answer is 3,500 millimeters. Therefore, para mas mabilis yung ating pag-solve, ang gagamitin natin ay yung 3,000 millimeters na effective length. Okay, so ngayon, kunin natin yung slenderness ratio. So recall natin yung kanyang formula, di ba? KL over R. So meron na tayong KL. Ngayon, ano yung R na gagamitin natin? Siyempre, since parehas naman kasing braced yung ating column, no? Parehas na direction sa X and Y axis. So, etong 3,500 millimeters na to, gagamitin siya in both RX and RY. So, which value of the radius of gyration will give us a higher value of the slenderness ratio? That is when the value of R is at minimum. Kasi nga, denominator natin R. So, dapat the denominator should be minimized and the numerator should be maximized. Diba? So, if the numerator is maximized, kaya natin pinili yung 3,500 millimeters. Since minimized dapat yung radius of gyration, tapos both axes nagagamit itong 3,500, so we will use the smaller value, and that is approximately 70.03, or that's the RY. So ang ating maximum value of KL over R is equal to 3,500 millimeters over 70.03 millimeters. And this gives us the value of approximately 49.98. And of course, it's unitless kasi nga, diba? Unitless yan kasi cancel yung dalawang mm, diba? So the answer for number 1 is letter A is 49.98. Alright, next question. Determine the design compressive strength of the column. Here we will use the National Structural Code. Bakit M? National Structural Code of the Philippines 2015. Yung pinaka-basic lang. So flexural buckling lang muna tayo, no? Alright, and since NSCP 2015, there are two methods na kino-consider. One is the ASD, or the allowable strength design, and meron tayong factor of safety or the omega that is 1.67. Then LRFD, we have the strength reduction factor. Kaya nga LRFD kasi load reduction factor. Tama. Load resistance factor. Yes, load resistance factor design. So phi is equal to 0.9. And actually, if you try to multiply these two, it gives us 1.5. Kasi yung 1.5 na yan, yung parang constant na parang difference between ASD and LRFD, no? So, yung product nilang dalawa, kahit tignan mo kahit sa flexure yan, sa bearing, 1.5 yung magiging sagot. Okay, so kunin muna natin yung nominal compressive strength ng ating column so that makuha natin yung mga design na values. P sub n, but for P sub n, we should check first the slenderness ratio. Okay? We will compare the slenderness ratio with this value, 4.71 square root of E all over Fy. Okay? Pero walang Fy sa ating problem. So, let's give a value of the yield strength na lang. No? Ang ginamit, I think, sa aking video na yun, it's 250. So, let's write 250. That's Fy. Anyways, kung hindi man yan yung nasa video, then so be it. No? Fy. We have 4.71. E is the modulus of elasticity of steel. That's 200,000 megapascals. Then we divide that by 250 megapascals. And the value here is approximately 133.22. So 133.22 actually yan yung critical slenderness ratio. Okay, parang dito yung boundary between long and short column. Parang ganun, di ba? So since KL over R, that is 49.98, is less than 4.71 square root of E all over Fy, so ang gagamitin nating value ng ating P sub n, meron actually yung formula yan, di ba? From the code, that's FCR area times the gross area. So, etong FCR na gagamitin natin since ito ay base dito ha. Ito, base siya dito. Yan. FCR is equal to 0.658 raised to Fy over Fe times Fy. And F sub E here is the Euler's critical buckling stress. So we have pi squared E all over KL over R squared. Right? So substitute lang natin. We have pi squared E, that's 200,000 megapascals all over yung ating slenderness ratio, 49.98 squared. And we have F sub E equal to 790.20 megapascals. Now, makukuha na natin yung FCR. That is 0.658. Substitute lang natin. Raised to 250 over 790.220. Yeah, 790.2. Times Fy, that is 250. FCR, therefore, is equal to, is actually approximately 219 megapascals. So, therefore, ang value ng ating nominal load ay, nominal compressive strength is 290 megapascals times the gross area, which is 2 times 4,500. 4,500 millimeter squared. Pero syempre, Newton yung ibibigay niyan. So let's divide that by 1,000 para maging kilonewton yung ating units. So P sub n is equal to 1,971 kilonewtons. Yan. So, meron na tayong nominal load. Makukuha na natin yung dalawang possible na design values. So, let's try ASD muna. So, P sub A or P allowable is equal to P sub N over omega. So, yun lang. 1971 divided by 1.67. 1971 over 1.67 is equal to approximately 1,180. 1,180.24 kilonewtons. And for LRFD, we have P sub U equals phi times P sub N. So, 0.9 ng 1971. And the answer here is 1,773.9 kilonewtons. So, ito na yung dalawang possible answers natin. We have 1,180.24, that is for ASD. And 1,773.9, that is for LRFD. Let's proceed to the last question for the practice problem. So if the design compressive strength is composed of 20% dead load and 80% live load, determine the service load that it can carry. So yung service load dito, yung unfactored, syempre. So solve muna natin yung dead load and live load. But consider this. Dito sa ASD, kailangan pa ba? No? Kailangan pa ba natin ng pag-solve ng dead load and live load? Di ba ang ASD niyan, hindi mo kino-consider yung factor, yung 1.2 and 1.6 for dead load and live load. Diretso lang, di ba? P allowable is equal to the dead load plus the live load. No need to have the factors kasi ASD nga. So therefore, DL plus LL. Ito na yung service load. So this is already 1,180.24 kilonewtons. Ito na yung ating answer for ASD. Bilis, no? Next, ito yung medyo mahirap. No? For LRFD, yung P sub U natin, yan yung may 1.2 DL dead load plus 1.6 live load. Pero sabi, 20% dead load, 80% live load. So, since 20% yung ambag ni dead load, 80% yung ambag ni live load, pwede naman natin kunin yung kanilang ratio. Let's express their ratio. So, we have the live load divided by the dead load is 80%. Sige, 80% divided by 20%. And we can actually have this relationship for live load and dead load, which is live load is equal to 4 times dead load. Yan ngayon isa-substitute natin dito sa may equation na to. Diba? So, ano yung P sub U natin? 1,773.9 equals 1.2 nung dead load plus 1.6 nung live load, which is 4 times dead load. Here, you can solve for the dead load. And the value of the dead load is 233.41 kilonewtons. Therefore, for the live load, 4 times dead load lang siya. So, 4 times 233.41. And that is 933.63 kilonewtons. So, we have the total service load. Dead load plus live load is equal to 1,167.04 kilonewton. And this is already our answer. So, ito yung sa ASD. Ito yung sa LRFD. And that's our answer for the practice problem in the Kippap Education YouTube channel. In my tutorial under compression members, that's in Still Design. So, thank you guys for listening on this discussion. Comment down below kung may masasuggest kayong next kung ituturo, next kung isosolve. Kaya wala, no? You can feel free to comment down below. Tapos kung gusto nyong sumali sa usapan din namin sa Facebook and Discord, details on the description. See you there. And peace out.